Now, having considered the method known as simultaneous equations by elimination, we now move on to simultaneous equations by substitution. It's a completely different method. It's far more useful because simultaneous equations by elimination only works if you have two straight lines on a graph. They have to be linear equations. So it's very limited. It doesn't let you deal with more complex equations, which is what ultimately we normally need to deal with. However, we're going to start today by looking at simultaneous equations by substitution, still with two linear equations, just because it's simpler to explain the process with a simple example. Before we go on to that, however, I want us just to recap a much simpler type of equation. 3x plus 1 equals 2x minus 7. Always set the equals down in a column. And consider that we have four options. We could subtract 3x off each side, we could subtract 1 off each side, we could subtract 2x off each side, or we could add 7 to each side. Four options, all of them valid, one of them being the best choice. Now, I hope that you remember this from previous lessons, but ideally you will remember to start with the letters. This is not a rule, it's a principle, a helpful principle, but it should make our life a lot easier. Start with the letters and consider those two options first. We could subtract 3x off each side. If we do that, then 2x minus 3x will give us negative 1x. And that negative x, whilst correct, is more complex than it needs to be. It's easier just to stick with positive values if you can. So for that reason, it's a much better choice to subtract 2x off each side so that we're left with a positive x there. The positive 1 is still here. That's a blank. Minus 7. And we've got that. We can now subtract 1 from each side. And we discover that x equals a very easy negative 8. Now, that as it stands does not relate to anything on a graph at all, simply because in here there is no mention anywhere of y. So although we can imagine some of this on a graph, perhaps, the lack of the letter y means that it can't be drawn on a graph. Now, let's come back here. Y equals 3x plus 1. Y equals 2x minus 7. You can see the similarity, I hope, with this. But now we are talking about two variables. It could be plotted on a graph. The first big difference when we compare this against simultaneous equations by elimination is that I've set this up in two columns rather than one equation underneath the other. And you'll see this every time we follow this method. Now, y equals 3x plus 1. Y equals 2x minus 7. When we solve simultaneous equations, what we're trying to do is we're trying to discover where the two lines meet each other on the graph. That is, when do they both exist in the same point at the same time? That is, when, for instance, do these y values match each other? Well, we can decide to set it up to ask that very question. If we want these y values to match each other, then when I read y equals 2x minus 7, I'm going to write down something else. Y equals 2x minus 7. And I've substituted, in the place of this y, I've substituted something that is the same as y. And I've replaced that y with 3x plus 1. Now, we've just talked about how to solve this equation. We're going to subtract 2x from each side so that we get x plus 1 equals negative 7. We can take 1 from each side. We discover that x equals negative 8. And the parallels between that and what we did in this recap should be obvious. This piece of working, which was a standalone question, now features inside this much longer answer. X does equal -8, but that is not the end of the question, because we still need to work out the corresponding y value. And the best way to do that is to bring this value and substitute it back in to this equation here. Y equals 3x, but we know that x is -8. Y equals 3x plus 1. Y equals -24 plus 1. Y equals -23. And so these two lines, if we were to plot them on a graph, they intersect at an x value of -8 and a y value of -23. And we have solved those simultaneous equations by substitution. Notice in the working, if I cover the right-hand side, all of this follows. You can see the working following down the page. If I cover this, you can see again the working following down the page. Also, I've left this section here deliberately blank so that as the reader reads it from top to bottom, they can see by the shape of the working on the page that the thoughts have progressed in that order. It's really helpful to have that blank space just to emphasize to the reader that this is what's happening first.